Hey guys, I'm Colten Pilgrim. I'm Tutorials' resident Flink expert and advisor. I've been working the data space for about 9 years, but in the past 4, I've been heavily invested in the Flink framework. I've used Flink in the past 2 roles that I've been in. The first role was with working in micromobility and transportation network companies. I helped cities enforce policies on things as large as an Uber and as small as a delivery drone. I'm currently working in the entertainment and advertisement space, where I develop and manage Flink jobs that produce terabytes of data every single day. Because, we got to make sure we see those ads that we all know and love. But that's enough about me. Today's topic is going to be windowing in Flink 101. Let's get started by breaking down the 3 types of windows that we will most commonly see in Flink jobs and the difference between event and processing times. For our first windowing use case, so say every 5 minutes, I want to know how many people entered the zoo. This is a perfect use case for something like tumbling windows. Tumbling windows have a fixed size and they do not overlap. So if I have a stream of visitors entering the park, let's say we're having animals visit the park. So between this time window that started at 12 and ended at 12:05, we have tiger and bear coming and visit the zoo. If we evaluated this window, we would get an output of 2. However, if we then went and evaluated this window here, only giraffe came and visited the zoo during this time window. So the output of this window would be 1. And then for windows 3 and 5, there were no visitors, so it would output to 0, or they wouldn't even emit anything at all. But for 4, Panda came all by himself 10 minutes after everybody else. So yeah, it evaluate to 1 for that one. For our next use case, for every 15 minutes, I want a rolling average of the number of visitors who entered the zoo. This is a perfect use case for sliding windows. So the difference between tumbling windows and sliding windows are that, so sliding windows do have a fixed time, but they can overlap, hence the name sliding windows. So in this use case, we have hour-long windows that slide every 15 minutes. The difference between this is that for tumbling windows, Tiger would have only ended up in 1 window between 9 and 9:15. So the output would have just been 1. However, in this scenario, Bear, he affects the output of these 2 windows because he occurred in the sliding overlap of these 2 windows. And same for Giraffe, he would affect the output of these 3 windows, and Panda, all 4. The final use case is, for every visitor at the zoo, I want to know the animals they visited. This is a use case for session windows. So say that we have, little armbands that we gave all of our visitors whenever they came and entered our park, and we track them throughout the park. In this case, we have visitor A, he got to the park at 9 a.m., and he put on his armband, and he went and visited the rhino first, and then the giraffe, and then the bear, and then the panda. The thing is, with session windows, they don't have a fixed start and end point. It's just whatever triggers the beginning of this. In our case, the visitor entering the park is what triggered the session open for this visitor. And then whenever he left the park, or his armband went outside of the park, to close the session. So we would evaluate the session, figure out which animals he visited, and produce a metric for it. And then the same can be said for visitor B and C. Now let's get on to the differences between event time and processing time. If you look at this graph, you'll notice on the x-axis that we have our processing time, which is referred to as wall clock time, because it's always the time that the processing of the event occurs. However, if on the y-axis, you'll see that we have event time. This is when the event actually occurred. It is not when the event is being processed. The watermark, on the other hand, is defined as the highest timestamp seen by your Flink job. It is used as a guide to tell if the data is late. So if you have a watermarking strategy that has an out of orderness set to 0, it means that your watermark will always match the highest event timestamp seen by your job. This will cause any data that comes in with a lower timestamp than the highest timestamp to be considered late, and it will not be processed by a window. However, if you were to adjust your out of orderness to say, I don't know, 5 minutes, and then a new event comes in with a lower value, a lower timestamp value than your watermark, then it's allowed to be processed as long as that timestamp is not larger than 5 minutes in the past relative to your watermark. And now let's move on to my favorite, best practices. For the first one we have, how do you know if your watermarking strategy is configured correctly? Well, the first thing I always do whenever I'm consuming from a data source is I try to determine its SLA. You might be able to get this from talking to the producers of the data that the stream is in. You also might sometimes have to do analysis for yourself if the people who are producing the data are maybe less technically savvy. This is the most important rule for processing stream data because we need to know the SLA and potentially how out of order our data is before we need to start deeming records as late and unprocessable. It also plays a part for how much state we have to store in our task managers before we can actually start processing the data. And if it's a really large SLA, we might want to actually start looking at something like Flink batch. The next one is, how do windows work, and how do I explain the concept of windows on a stream? Windows on a stream really aren't that much different than windows on something like Spark or SQL. The only major difference is that Flink doesn't know the data that the windows will be processing when it's building its job graph. Whereas with Spark, as soon as the metadata for the data has been read in, it's going to build out a plan, and it knows exactly which windows it's going to be computing. The final question is, how do I know if all of my events made it to a window? Well, we all know that Flink can be a bit of a black box when it comes to knowing what events made it to which operator, I'm sorry. But you can specify a side output for your late data to be sent to. And from there, you can generate metrics on your side output, which is late data, or you can even process it like you would any other stream. However, if you do want to know how to look into your Flink jobs, basically using X-ray, there is the tool called Tutorials, and it's your best friend. It provides a nice visual layer over their vast data observability tools. Actually, here, let me pull up one of their job analyzers. Here I have one of my jobs pulled up in the Tutorials job analyzer tool. So as you can see, it has a pretty good high-level overview of a Flink job. This is from one of the runs that I was doing this weekend. I was trying to figure out some problems with my data. You can zoom in on this event time graph or timeline, and you can see every single event that came into this job. And for a short run of only 2 minutes, this had 3,325 events. And then if you come over here to the right, you'll see the visual representation of your job graph. And then you can actually toggle off which operators you want to see in the event timeline. So for this case, we're going to turn all of them off except for our window. And then here you have your operator inside of this tab view. Since I have all of my other operators turned off, this is the only one that shows up. And the nice thing about this is, so what we're viewing is, our window. These are the inputs to our window, and these are the outputs. You can actually view the individual events that make up the output of your window on your job graph. So here we can see, this one emit had 5 events, and they're highlighted over here in our inputs and on our timeline. So what's nice about this is whenever we, highlight our window, we actually can investigate it. So for this one, we can see that this window was made up from 5 events. In this run, I was actually expecting these to be about 12, but this window, should have more data. And by, looking at this, the data doesn't look that bad, actually. So we have, We move on to the right, which down here this is processing time, and then up here it's event time. Let's go look at another window. Ooh, yeah, so this is bad. So as you can see here, we have our red, which is our watermark, and we can see, our data might be out of order because we start going up and then it jumps back down and then starts going back up again as we get higher in our processing time. As I explained earlier when I was explaining to you the difference between event and processing time, we would hope to see as we increase in processing time, event time would also always go up with it. Whenever you have this case, it means that you probably misconfigured your watermark strategy. Well, it means that the data is out of order, but you probably misconfigured your watermark strategy. And if you're seeing some wonky results like I was, and you're seeing bad data come out of your windows, you can actually come out here and see, yeah, that's a lot of red. That's how many events didn't never make it to a window, and they were just completely ignored by Flink. If I wouldn't have had tutorials, I couldn't have actually visualized this. I would just be kind of scratching my head and having to do it the old-fashioned way by manually working backwards. I hope you guys are as excited as I am about the Tutorials Job Analyzer. As a Flink developer, I really do appreciate the work and effort that they put into their tooling, and with the many new features on the horizon, it's only going to get better. If you want to give it a try, you can head over to tutorials.com and sign up for free. What do you have to lose except for a better Flink experience? Thanks for watching.